Hi class, in section 9.4 we're looking at sum to product and product to sum formulas. So once again in calculus sometimes it's difficult to integrate the product of two trig functions, but it's much easier to integrate their sum or their difference. So here are four formulas that can be used. So let's look at the very first example. The first example says write the product as a sum. As you can see, this is a product of cosine times cosine. We want to write it as a sum. So therefore, we're going to use the very first formula because it's in the form of cosine times cosine. So let's write what alpha is equal to. Alpha is equal to 2 theta in this case. And beta is equal to 4 theta. So now we can write out the formula. Cosine of 2 theta times cosine of 4 theta is going to equal to 1/2 times cosine of the difference of the two angles plus the cosine of the sum of the two angles. So at this point, we just have to simplify this. So all you got to do is subtract, and that'll give you negative 2 theta for the first term. For the second term, you're going to get cosine of 6 theta. However, we also know that cosine is an even function, which means that the cosine of a negative angle is equal to the cosine of the positive angle. So lastly, we can write it in this form: cosine bracket cosine of positive 2 theta because it's an even function, and cosine of 6 theta. So that'll do it. That is our final answer. Okay, let's move on to the next example. All right, here we have the product of sine times cosine. So that means we're going to use the second formula up here. The second one is the form that we need. So it's going to be sine sum plus sine difference. All right, let's go ahead and write that out. So once again, we have alpha, in this case, is 4 theta, and beta is 2 theta. So sine 4 theta cosine 2 theta is going to equal to 1/2 sine 4 theta plus 2 theta plus sine 4 theta minus 2 theta. And once again, we simplify this. 1/2 times sine of 6 theta plus sine of 2 theta. And that's as far as we can go there. So we are done. Okay, moving on to the next page. Now we have the formulas that are going to go in the opposite direction. The sum to product formula, sum to product. And same thing, there are 4 of them. So let's go see how this is going to be used. So this time they want us to write the difference in terms of a product. And it tells you here that these are particularly useful when verifying identities or solving equations where a sum equals 0. Okay, so in this first example, we are going to use the second formula. It's in that form of the second one. So let's go ahead and apply it. So alpha, once again, is the first angle, 4 theta. Beta is the second one, which is 2 theta. So now when we apply the formula, it's going to be sine 4 theta minus sine 2 theta is going to equal to 2 sine the difference, 4 theta minus 2 theta, over 2 times the cosine of the sum of alpha plus beta over 2. And if we simplify this, we'll get 2 sine 4 theta minus 2 theta is 2 theta. 2 theta divided by 2 is simply theta. And over here we get 4 theta plus 2 theta is 6 theta. 6 theta divided by 2 is 3 theta. And that takes care of that problem. Okay, moving down. We have another problem here. So it's same thing, except now they're giving you the angles in degrees. So cosine minus cosine will be the last formula, this one here. Okay, so let's apply it. Remember that alpha is the first one, 15 theta. Beta is the second one, 75 theta. So cosine of 15 degrees minus cosine of 75 degrees is going to equal to -2 sine of the sum divided by 2, 15 degrees plus 75 degrees over 2, times sine the difference, 15 degrees minus 75 degrees over 2. And if we simplify that, we will get -2 sine of 15 plus 75 is 90, divided by 2 is 45 degrees. And over here we have 15 takeaway that will be 60, 50 divided by 2. That is going to be 15 take away 75 is 50, I believe. Sorry, 60. 60 divided by 2 is 30. There we go. All right, now we can use the unit circle. And if you look at the problem, it does say that they want the exact evaluation of this. So we can use our unit circle. If you use your unit circle, you're going to get radical 2 over 2 for sine of 45. And for sine of 30, you should get 1/2. So this turns out to be, if you cross out the 2's, cancel out the 2's, you'll have negative radical 2 over 2 as our final answer. That does it. Okay. Let's move on to the next page. The final page of this section. So this is a verifying identity problem. So in this case, we are going to use the cosine minus cosine formula. The cosine minus cosine formula. Okay, so let's rewrite the left side in order to make the left side equal to the right side. So if you rewrite the left side, the formula is going to be negative. It's the last of the 3. Let me use blue for this. -2 sine the sum, 4t plus 2t is 6t. 6t, I'll just write it out. 4t plus 2t over 2 times sine of the difference, 4t take away 2t over 2. So that is the numerator. Now let's write the denominator of the left side. So sine plus sine is going to be the first formula. If you're looking at the formulas, it's the first one of the 4. So it's going to be 2 sine the sum of the sum divided by 2 times the cosine of the difference. 4t minus 2t over 2. Okay, and if you simplify, oh, we still have the right side is the same as the right side of the original problem. Now let's see if we can simplify this. All right, so this becomes -2 sine. Well, this becomes 6t divided by 2 is 3t. And this becomes 4t, take away 2t is 2t, divided by t is just t. And over here we have the same thing. The sum is 3t divided by 2 is 3t. And the difference is 2t divided by 2 is just t. Okay, as you can see, we have cancellation of the 2's, so you have a negative in the numerator. These cancel out completely. And now we have sine over cosine of t, which is tangent by definition. So now we just have -tan of t equals -tan of t. That completes the verification. Great. Let's move on to the last one. This is also a verify the identity type of problem. So let's see what we could do. It looks like on the left side, we can rewrite tan and cotan. Well, tan, by definition, is sine theta over cosine theta. Cotangent, by definition, is cosine theta over sine theta minus cosine squared. And we want to show that that is equal to sine squared. Well, over here you have cancellation of sines and cosines, so we're left with 1 minus cosine squared. And we know that 1 minus cosine squared that's just a variation of the Pythagorean identity. That's the same thing as sine squared. So that takes care of this one. And that completes this section.